Hello everyone, a warm welcome to the next session of machine learning with Python programming. How are you guys? I hope everyone is fine and everyone is learning machine learning concept with the help of Python programming from my first session to till now. Yes? Okay. By the way, I hope you remember types of machine learning. Yeah. In which we have seen supervised machine learning, unsupervised machine learning, reinforcement learning, and semi-supervised learning. Yes. Now, when it's come to the supervised machine learning are classified into two categories of algorithm. First one is regression. Next one is classification. Remember? Yeah, do you remember that? Okay. So under the regression, we have seen simple linear regression, multiple linear regression, and polynomial regression. Right? Now let's proceed with the next point, that is classification. Okay. So in this session, we are going to start with the classification part 1. Okay. So let me show you what you are going to learn in this session. So we are going to start with the first question. What is a classification? And then the classification terminologies in machine learning. Okay. After that, we will see the types of learner in classification, and then logistic regression, and finally the example on logistic regression. Okay. Now you might be thinking it look like regression here, logistic regression. Is it a regression? No, this comes, logistic regression comes under classification. Okay. In case of a regression analysis, in case of a regression, we have seen simple linear regression, multiple linear regression, and polynomial regression. Now we started with the classification. Okay. So I'm going to explain you each of these points in detail in this session. Okay. So let's start with the first point. What is classification? Okay. In machine learning, classification is a supervised learning approach which can be thought of as a means of categorizing or classifying some unknown items into a discrete set of classes. Okay. In machine learning, classification is a supervised learning approach which can be thought of as a means of categorizing or classifying some unknown items into a discrete set of classes. Classification attempts to learn the relationship between a set of feature variable and a target variable of interest. Okay. Classification attempts to learn the relationship between a set of feature variable, or you can say independent variable, and a target variable of our interest. Okay. Classification is a process of categorizing a given set of data into classes. It can be performed on both structured or unstructured data. The process starts with predicting the class of the given data points. The classes are often referred to as a target, label, or categories. The classes are often referred to as a target, label, or categories. It is a kind of learning where the algorithm needs to map the new data that is obtained to any one of the two classes that we have in our data set. Okay. The main goal of classification problem is to identify the category or class to which a new data will fall under. An easy to understand example is classifying the email as spam or not spam. Are you getting it? The main goal of classification problem is to identify the category or the class to which the new data point will fall under. Okay. An easy to understand example of classification is classifying an email as spam or not spam. Okay. Now let's proceed to the next point. Classification terminologies in machine learning. So now let's understand some of the terminologies for classification. Okay, so first one is classifier. What is this classifier? It is an algorithm that is used to map the input data to a specific category. Okay, so classifier, it is an algorithm that is used to map the input data to a specific category. Okay, now what is the next terminology? Classification model. The model predicts or draws a conclusion to the input data given for training. It will predict the class or category for the data. Okay, so classification model is going to predict the class or category of the category for the data. Okay, now next one is feature. A feature is an individual measurable property of the phenomenon being observed. A feature is an individual measurable property of the phenomenon being observed. What is the next term? Binary classification. It is a type of classification with two outcomes. For example, either true or false, or you can say, for example, gender classification, such as male, female. Okay, so it is a binary classification. So it is a type of classification with two outcomes only, either true or false, or you can say gender classification, male, female. Okay, are you getting it? Yeah. So classifier, it is an algorithm that is used to map the input data to a specific category. Classification model, okay, it is going, this model is predict or draw the conclusion to the input data given for the training. It is going to predict the class or category for the data. Okay, and next term is feature. A feature is an individual measurable property of the phenomenon being observed. And then binary classification. It is a type of classification with only two outcomes. For example, either true or false, or you can say gender classification, such as male or female. Now next term is multi-class classification. The classification with more than two classes. In multi-class classification, each sample is assigned to one and only one label or target. What is multi-class classification? The classification with more than two classes. Okay. In multi-class classification, each sample is assigned to one and only one label or target. Okay. Now next one is multi-label classification. This is a type of classification where each sample is assigned to a set of labels or targets. Got it? So remember these classification terminologies. Okay. So we have seen classifier. Okay. And then we have seen classification model, feature, binary classification, multi-class classification, and multi-label classification. Okay. So remember these terminologies. Okay. Now let's see the next point. Types of learner in classification. Okay. There are two types of learner in classification as lazy learner and eager learner. What is this? There are two types of learners in classification as first one is lazy learner and eager learner. So let's see what is lazy learner. Lazy learners simply store the training data and wait until a testing data appears. The classification is done using most related data in the stored training data. They have more predicting time compared to eager learner. Okay. For example, K nearest neighbor, case-based reasoning. Okay. So these are the learner. For example, a K nearest neighbor, KNN. We are going to see that also in our later session with its theory, with its example, with its implementation. Okay. Okay, so there are two types of learner in classification. First one is lazy learner. Second one is eager learner. Lazy learner simply store the training data and wait until a testing data appears. The classification is done using the most related data in the stored training data. They have more predicting time compared to eager learners. Okay, the example of lazy learner are K nearest neighbor, case-based reasoning. Okay, now let's see what is eager learner. Eager learners construct a classification model based on a given training data before getting the data for prediction. It must be able to commit to a single hypothesis that will work for the entire space. Due to this, they take a lot of time in training and less time for a prediction. Example for eager learners are decision tree, Navy bias, artificial neural networks. Okay. So these are the types of learner in classification, lazy learner and eager learner. Okay. So what is the difference you are finding here? Lazy learner simply store the training data and wait until a testing data appears. Whereas eager learner construct a classification model based on the given training data before getting the data for prediction. Eager learner must be able to commit to a single hypothesis that will work for the entire space. Yeah, eager learner must be able to commit to a single hypothesis that will work for the entire space. Due to this, they take a lot of time in training and less time for a prediction. Okay. In case of a lazy learner, they have more predicting time compared to eager learner. Okay. So remember, eager learners must be able to commit to a single hypothesis that will work for the entire space. Due to this, they take a lot of time in training and less time for prediction. Example for eager learners are decision tree, Navy bias, artificial neural network. Okay. Now let's see the classification algorithms. That's very important. There is a lot of classification algorithms available now, but it is not possible to conclude which one is superior to other one. It depends on the application and nature of available data set. Okay, so there is lot of classification algorithms available, but it is not possible to conclude which one is superior to other one. It depends on the application and nature of available data set. Okay, so if you classify the classification algorithm, so you can classify it into mostly two types, linear models and then non-linear models. So under the linear models, you have the logistic regression and support vector machine. Okay, and under the non-linear models, you have K nearest neighbors, kernel support vector machine, Navy bias, decision tree classification, and random forest classification. Okay. So all these are the classification algorithms. So you mostly, if you talk about, you can classify the classification algorithm broadly into two categories, linear models and non-linear models. So under the linear model, you have the logistic regression and support vector machine. And under the non-linear models, you have K nearest neighbor, kernel support vector machine, and then Navy bias, decision tree classification, and random forest classification. Okay. So all these are the classification algorithms. So let us look at the first classification algorithm, okay, in machine learning. So first one is logistic regression. So let's start with this one. Okay. What is logistic regression? It is one of the classification algorithm. Okay. So see here, logistic regression is analogous to linear regression, but tries to predict a categorical or discrete target field instead of numeric one. Yeah, in case of a linear regression, you try to predict the real value in terms of numerical numbers. Yeah. In logistic regression is analogous to linear regression, but it tries to predict a categorical or discrete target field instead of numeric one. Logistic regression is a classification and not a regression algorithm. Make a note for it. Logistic regression is a classification and it is not a regression algorithm. It estimates discrete values such as binary values like 0, 1, yes or no, true or false, based on a given set of independent variables. Are you getting it? Logistic regression estimates discrete values such as binary values like 0, 1, yes, no, true, false, based on a given set of an independent variable. Simply put, it basically predicts the probability of occurrence of an event by fitting data to a logged function. Hence, it is also known as logged regression. The values obtained would always lie within 0 and 1 since it predicts the probability. Okay. So remember, logistic regression is a classification and it is not a regression algorithm. Logistic regression estimate discrete values such as binary values like 0, 1, yes or no, true or false, based on a given set of independent variables. Simply put, it basically predicts the probability of occurrence of an event by fitting the data to a logged functions. Hence, it is also known as logged regression. The values obtained would always lie within 0 and 1 since it predicts the probability. Okay. We use logistic regression for binary classification of data points. Okay. We use logistic regression for the binary classification of data points. Okay. We perform categorical classification such that an output belongs to either of the two classes, such as true, false, 1 or 0. Okay. For example, we can predict whether it will rain today or not based on a current weather conditions. The goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variables. What is the goal? The goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variables. It is better than other binary classification algorithms like nearest neighbor since it quantitatively explains the factor leading to the classification. Okay. Now what you might be thinking, what is this nearest neighbor? So we are going to study that in our later session. So don't worry. So are you getting what is the logistic regression? Yeah. The main goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variable. Okay. And we use the logistic regression for the binary classification of data points. We perform categorical classification such that an output belongs to the either of the two classes, 1 or 0, true or false. For example, we can predict whether it will rain today or not based on with the help of logistic regression. And logistic regression is analogous to the linear regression, but it tries to predict a categorical or discrete target field instead of numeric one. Logistic regression is a classification and it is not a regression algorithm. It estimates discrete values based on a given set of independent variables. Okay, got it? Logistic regression is a fundamental classification technique. It belongs to the group of linear classifier and somewhat similar to the polynomial and linear regression. It is somewhat similar, okay? Logistic regression is somewhat similar to the polynomial and linear regression. Logistic regression is fast and relatively uncomplicated, and it's convenient for you to interpret the result. Although it's essentially a method for binary classification, it can also be applied to multi-class problems. Got it? Yeah. So logistic regression is a fundamental classification technique. Okay. Logistic regression is fast and relatively uncomplicated, and it's convenient for you to interpret the result. Although it's essentially a method for binary classification, it can also be applied to a multi-class problems. Got it? So I hope you got an idea about logistic regression. Yeah. What is logistic regression? The goal of logistic regression. What does it predict? Yeah. It predicts the output in terms of discrete values. Yeah. It predicts the output in terms of discrete value, such as binary values like 0, 1, yes, no, true, false, based on a given set of independent variable. So logistic regression, it is a classification and it is not a regression algorithm. It estimates discrete values based on a given set of independent variables. Okay. We use the logistic regression for a binary classification of data points. Okay. So got it. The goal of logistic regression is to find the best fitting relationship between the dependent variable and a set of independent variable. Okay. Logistic regression is a fundamental classification technique. Logistic regression is a fast and relatively uncomplicated, and it's convenient for you to interpret the result. Got it? So remember this point about a logistic regression. Okay. Now it's time for us to see the example on logistic regression. Let's now see how to apply the logistic regression in Python using a practical example. Okay, so what is our example here? Our goal is to build a logistic regression model in Python in order to determine whether the candidate would get admitted to a prestigious university. Okay, based on the score of GMAT, GPA, work experience. Okay, so our goal is to build a logistic regression model with the help of Python programming in order to determine whether the candidate is going to get the admission into the university based on his score on GMAT, based on GPA, and based on work experience. Okay. So let's build a logistic regression model step by step. So the first step is import the needed Python packages or the modules. Before you start, make sure that following packages are installed in Python. First one is pandas, yeah, which is used to create a data frame to capture the data set in Python, and then sklearn, which is used to build a logistic regression model in Python, and finally matplotlib, which is used to display the chart if you want to display, otherwise not. Okay, so the first step for creating or building the logistic regression is import the necessary Python packages. Okay, what is our goal? What is our problem? We need to find whether a student will get admission into the university or not based on GMAT score, GPA, grade point average, and the work experience. Okay. So the first step is import the needed Python package. Now next step is, so see here, import the needed Python package. You will then need to import all the packages as follows. So see here. First import the pandas SPD, okay, so that we can read data from the CSV file. And then from sklearn, dot model underscore selection import train underscore test underscore split. And then from sklearn dot linear underscore model import logistic regression. And finally import matplotlib.pyplot.splt. So here from sklearn dot model underscore selection import train underscore test underscore split is useful to split the arrays or matrices into a random train and test subset. Okay, if you want to split your data set into training set and testing set, then you need to use this one from sklearn dot model underscore selection import train underscore test underscore split. And then from sklearn dot linear underscore model import the logistic regression so that we can build a logistic regression model. And finally import matplotlib.pyplot as plt. Okay, so the first step is import the needed Python package. Now, if once you imported it, let's see what is the next step. Next step is gather your data. Let's look at the data set. So let me show you the file. Okay, the CSV file. The name of the CSV file is admission. So see here, this file has total 4 columns. GPA, GMAT, GPA, work experience, and admitted. Okay, what is our goal? Our goal is to find or to predict whether the student is going to get the admission based on a GMAT score, based on the GPA and the work experience. So see here, we have the GMAT column, GPA column, work experience, and admitted. So how many rows we have? Total 40 rows or 40 observation we have. Okay. So here there are 2 possible outcomes. First one is admitted, represented by the value of 1 versus rejected, represented by the value of 0. So see here, admitted 1, 1, 0. So 1 means the student got the admission. 0 means the student doesn't get the admission. So if the student has 690 marks in GMAT with a GPA of 3.3 and the experience, total experience of 3 years, then the student got rejected, 0. But if the student has a GMAT score of 750 with the GPA of 3.9 with a total work experience of 4 years, then the student got admission here. You can see from the 1 and 0. So here there are 2 possible outcomes, 1 and 0. 1 means the student got the admission, 0 means student got rejected. Okay, you can then build a logistic regression in Python where 3 independent variables are GMAT score, GPA, and years of work experience. And the dependent variable represented whether a person get admitted or not. Yes, by looking at this data set, we can say that we are going to build a logistic regression in which we are going to have GMAT, GPA, and work experience. Okay, GMAT, GPA, and work experience. We are going to consider these 3 as an independent variable. Yes, the 3 independent variables are GMAT score, GPA, and years of work experience. And what is our goal? Our goal is to find whether the student will get the admission or not. So hence we can say this one, admitted will be our target variable or dependent variable. Got it? Dependent variable represent whether the person or the candidate gets the admission or not. Are you getting it? Yes. So once we imported the necessary modules, after that, gather your data. Let's look at the data set. So we have looked to the data set. So as per our problem, we need to find whether the candidates will get admission to the prestigious university or not based on his score on GMAT, GPA, and then based on work experience. So hence we can classify, hence we can say there are total 3 independent variables, GMAT score, GPA, and years of experience. And we have 1 dependent variable or a target variable, that is this one, admitted, that will show us whether the candidate got the admission or not. So here 1 represent the student got the admission, whereas 0 represent the student get rejected. Okay, got it. Now, what is the name of my file? The name of my file is admission.csv. So how can I read it? It's very easy. So here you need to divide the given columns into 2 types of variable. Okay. Here you need to divide the given columns. We have total 4 columns: GMAT, GPA, work experience, and admitted. So here we need to divide the given columns of our data set into the 2 types of variable: dependent or variable or target variable, you can say, and independent variable, or you can say a feature variable. Okay. So how we need to divide it? We need to divide the given data set. Okay. We need to divide the given columns of the data set into 2 types of variable: independent variable and dependent variable. Okay. Now we need to set the independent variable. What is our question? Our question is to find whether the student get the admission or not based on the GMAT score, based on the GPA and the work experience. So hence we can say, we can set the independent variables, okay, represented as X. Okay. So see here, GMAT, GPA, work experience. So we have given the columns. We have divided the columns into 2 types. First one is independent variable and dependent variable. So GMAT, GPA, work experience, these are the columns you can consider as a independent variable, because based on the GMAT score, based on the GPA, based on the work experience, we are going to predict whether the student get the admission or not. So hence we can say this, we can set the independent variables represented as X, and then we can set the columns GMAT, GPA, work experience under df of square bracket, df of square bracket, set it to the variable X. So here X represent the independent variable. Okay. So in our data set, we have total 4 columns in our, GMAT, GPA, and work experience. Based on these 3, we need to predict whether the student get the admission or not. Hence this 4th column, admission, or you can say the admitted, it will be the dependent variable or a target variable. So you can assign GMAT, GPA, work experience to the variable X, that is represented here as an independent variable, and you can assign this column admitted to the variable Y, that is our dependent variable. Got it? Now how can I access the variable GMAT, the column GMAT, GPA, work experience? Tell me, from the data frame, how can I access it? Yeah, let's suppose it's a data frame. So how can I access it? Like this: df of square bracket, GMAT, GPA, work experience, and df of admitted. Before that, you need to read a file from the CSV, and the result of this one you need to assign to the variable df. Now let's perform these steps till step 3. Okay. So first of all, you need to open the Jupyter notebook. Can you see this one, Jupyter notebook, Anaconda? Once you open it, you will find this one. Okay, like this one. Here you can see, to access the notebook, open this file in a browser. So copy this one and paste it in a browser. Okay. Once you paste it here, it look like this one. And then go to the new file and then click on Python 3. Okay. Now it's already, I have opened it. So see here. What is our first step? First step is to import the necessary Python packages or the modules. So see here, import panda.spd so that we can read and data from the CSV file. And then from sklearn.model_selection, import train test split so that we can split our data set into training set and testing set. And then finally, and then from sklearn.linear model, import logistic regression so that with the help of this one, we can build a logistic regression model. Okay, and then import matplotlib.pyplot and splt if you want to plot. Okay, so once we import it, next is to have a look at the data or to read a data from the CSV file. So this is our file that contains 4 columns: GMAT, GPA, work experience, and admitted. Okay, so how to read it? It's very easy. We have a function pd dot read underscore CSV. So what is this pd? Pandas dot read underscore CSV, and then inside a parenthesis, inside a single quote, specify the location where this file is present. The result of this one you can assign to the variable df. So df is a data frame object that is going to contain all the data which you have in this file admission.csv. And then if you want to look at the initial 5 rows of this data set, you can check it like this one, df.head and then df.tail. Now let me execute the first one. So it's executing. Okay, and then this one. Okay, and then let's suppose if you want to see the initial 5 rows or 5 observation of our data set df. Okay, so just wait till the time that it get executed. So see here, so df head. So this is our whole data set. Now if you want to access the column GMAT, GPA, and work experience, how can you access it? It's very easy. You just need to write, you see here, all these 3 records are executed, df.head. You can see the initial 5 observations, 0, 1, 2, 3, 4, with the column GMAT, GPA, work experience admitted. If you want to see the last 10 observation, then you need to write df.tell 10. Now let me execute it. It is going to show us the last 10 observation of our data set. Okay, so just wait. So what is our last 10 observation? You can see here. So see 640, what is the answer we are getting? Just wait. By the way, it is going to show us the last 10 observation or the last 10 rows of our data set, this one. Okay, now what is this whole? We have assigned it to the variable df, data frame object. Okay, now if you want to access a particular column of your data frame, how can you access it? If you want to access these columns, which columns? GMAT, GPA, and work experience. How can you access it? It's very easy. You just need to write the name of data frame, df, and then inside a square bracket, specify the name of the columns that you want to access. So see, what is our problem? Our problem statement is whether the student is going to get the admission or not based on the GMAT score, based on the GPA and work experience. Hence, we are accessing GMAT, GPA, and work experience at one time, and we have assigned it to the variable x, that is nothing but the independent variable. Yeah, it's an independent. Why? Because using these columns, GMAT, GPA, and work experience, we are going to predict whether the student get admission or not. So hence, you can access GMAT, GPA, and work experience, and the result of this one you can assign to the variable capital X. That is our independent variable. And what is this one? Fourth one. We want to predict this one, whether the student get the admission or not. Hence, this is our target variable or a dependent variable. So you can access, how can you access this column? It's very easy. Just write df of a square bracket inside a single quote, specify the name of the column that is admitted. The result of this one you can assign to the variable y, that is our dependent variable or a target variable. Are you getting it? Yes. And then you just need to execute it. So it's executing. Okay. So I hope you are clear with the first 3 steps. First one is import the necessary Python packages or the module. And then next one is, let's look at the data set. Yeah. So we have a data admission.csv. So we have read it with the help of pandas.read underscore CSV. Okay. The result of this one we have assigned to the variable df. Okay. So this data frame df, it's going to contain all the data that we have in this CSV file. If you want to look at the initial 5 observation, so you can write df dot head 5. If you want to look at the last 10 observation, so you can write df dot tail 10. Okay. And then see here in the second step, here the outcomes are, here there are two possible outcomes. First one is the student is going to get the admission or student going to get rejection. So yeah, you can see here 1 represented by the student got admission, 0 represent the student doesn't got the admission. Okay. Are you getting it? So here there are two possible outcomes. Admitted represented by the value of 1, rejected is represented by the value of 0. Okay. You can then build a logistic regression in Python where the 3 independent variables are the GMAT score, GPA, and years of experience. Yeah, these 3 columns, GMAT, GPA, and work experience. And the dependent variable admitted. The dependent variable represent whether the person get the admission or not. Okay. So we can divide the given data columns into 2 types of variable, independent variable and dependent variable. So independent variables here will be these 3 columns. Which one? GMAT, GPA, and work experience. Because based on this one, we need to predict whether the student will get the admission or not. Okay, so hence we have written df of square bracket, GMAT, GPA, work experience. Okay, so this means we are accessing these 3 columns of the data frame df. And the result of this one we assign to the capital X. And then how to access the 1 column? This one, last one, admitted. It's very easy. df of square bracket inside a single quote, like the name of the column. Yes? Are you getting it? Yeah. So I hope you have understand the initial 3 steps. First one is importing the necessary modules of the packages, and then reading a data from the CSV file, and then classifying or dividing the columns, given columns into 2 types, independent variable and dependent variable. So we have put the columns GMAT, GPA, and work experience under the independent variables. We have assigned it to the variable X, and our target variable will be this one. Why? Okay, it is the column admitted. Yeah, why we dividing the GMAT, GPA, and work experience? Why we are saying it is the independent? Because our question is to find whether the student will get the admission into a prestigious university based on GMAT, GPA, and work experience. So hence, we have classified the given columns into 2 types of variable, dependent variable and independent variable. Okay. So based on the GMAT, GPA, and work experience, we need to predict whether the student will get the admission or not. Hence, we have put these columns, GMAT, we have access, GMAT, GPA, and work experience, these columns, and we have assigned it to the variable X, that is our independent variable. So X is independent variable that contain all the data set which is present under the column GMAT, GPA, and work experience. Whereas our 4th column, that is our data set, that is our admitted. This one, the 4th column is our target one. Yeah. Hence we have put it, we have assigned it df of square bracket admitted, we have assigned it to the variable Y, and Y is nothing but our target variable or dependent variable. Got it? So I hope you understand why we have put in these 3 columns, why we assign these 3 columns to the independent variable X, and why we assign this one to the dependent variable Y. Because based on the GMAT, GPA, and work experience, we need to predict this one, the student got the admission or not. Got it? Yeah. So what I will do, I will continue with the next point, that is our step 4, splitting the data in our next session. But as of now, I hope you understand what is classification. Yes, I hope you understand the classification. And what is the logistic regression? The goal of logistic regression. Yeah. Yeah, logistic regression is not a regression, but it is a classification. See here. Logistic regression is a classification and not a regression algorithm. Make a note of it. Okay. The main goal of this one is, what is the main goal here? The goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variable. Okay. Logistic regression estimate a discrete value such as binary value like 0, 1, yes or no, true or false, based on a given set of independent variables. Okay. So our question is, what is our question? Based on a given set of independent variables such as based on the GMAT score, based on the GPA and based on the work experience, we need to predict whether the student is getting the admission or not. So admitted means it is represented with the value 1. Rejected means it is represented with the value 0 in our data set. You can say this one. Yeah, admitted 1. Rejected means 0. Okay. And I hope you understand what is the classification, logistic regression, and the example in which we have performed the 3 steps to build a logistic regression. And I hope you also clear with our goal. Yeah, we are building the logistic regression model with the alpha Python in order to determine whether the candidates would get the admission into the prestigious university. So we have looked at the first step, we have imported the necessary Python packages, and then we have looked at our data set, we have gathered our data set, we have understand our data set, yeah, and based on the problem, we have classified our data set or given columns into the 2 types, independent variables and dependent variables. Hence, GMAT, GPA and work experience, we have assigned it to the independent variable X because based on the GMAT, GPA and work experience, we need to predict whether the student will get the admission or not. So it's our independent variables. So the result of this one is X. X is our independent variable that contain all the data of the columns GMAT, GPA and work experience. Whereas this admitted, this column is, we are considering it as a dependent variable or target variable. Hence we have assigned it to the variable Y. So I will continue with the next point of splitting the data in our next session. Okay. Yeah.